It's time now for operations on radical expressions. We can add 2x squared and 5x squared to obtain 7x squared because they are like terms. We can also add and subtract like radicals. Like radicals have the same index and the same radicand. For example, we can add 3 square root of 2 and 5 square root of 2 because they are like radicals. So we basically add their coefficients. 3 plus 5 is 8. So our answer is 8 square root of 2. All right, let's get busy and practice some. If possible, add or subtract the expressions and simplify. Assume that all variables are positive. So that just means we are not going to need any absolute values. And that just restricts our domain so that we know all variables are positive. Here we go. Let's get going. Number 1, 2 square root of 3 plus 8 square root of 3. Same index, same radicand. So 2 plus 8 is 10. Number 2, same index, same radicand. 7 plus 2 is 9. So our answer is 9 cubed root of 2. Number 3, 3 square root of 6 plus 6 square root of 3 is simplified. They are not alike. Number 4, same index, same radicand. We can subtract. 4 minus 2 is 2. So our answer is 2 cubed root of 5. Number 5, well, we have like terms right here. So there's a 1 in front of that. So we can add 1 plus 3, 4 square root of m minus 7 square root of n. Now number 6 can be simplified. Square root of 75, we need to simplify that. So that's 25 times 3, 5 times 5 times 3. So that simplifies into 5 square root of 3. And then we have minus 4 square root of 3. Same index, same radicand. 5 minus 4 is 1. So our answer is square root of 3. Number 7. The square root of 12 needs to be simplified. So we need to take 2 times the 3 that's already out in front. So that's going to be 6. So I'll write this. This is a 3 times that 2, which is that 6. So we have 6 square root of 3 plus 7 square root of 3 plus 7 square root of 5. So we can combine 6 plus 7, 13 square root of 3 plus 7 square root of 5. Number 8, we need to simplify the cubed root of 108. So I'm going to make my factor tree. So the cubed root of 108 simplifies into 3. Cubed root of 4. And we have plus 8. Cubed root of 4. They both have an index of 3, a radicand of 4. So we can add 8 plus 3. So our answer is 11 cubed root of 4. Number 9. the cubed root of d to the 6th. How many groups of 3 are in 6? So that simplifies to d squared. How many groups of 3 are in 3? 1. So that just simplifies into d squared minus d. Number 10, we need to simplify the radicals. 7 square root of 3n is simplified. Plus, we can simplify the square root of 12. That's 2 times 2 times 3. So that's going to be 4 square root of 3n. And 27 is 3 times 3 times 3. That's going to be 3 square root of 3n. So now we can combine 7 plus 4 minus 3. Number 11, the square root of 36 is 6. And then if we simplify x cubed, we have a pair of x's, and then a factor we didn't use. The square root of 4 is 2. We have the same x's. So we have a pair of x's. We have an x that goes back under the radical sign. So now we can take 6x minus 2x. That's 4x and square root of x. Number 12, we need to have a common denominator. So the least common denominator, or the least common multiple of 3 and 6, will be 6. So I need to multiply this first fraction by 2 over 2. So I have 8 square root of 3 over 6 plus square root of 3 over 6. You can put a 1 right there if you'd like. 8 plus 1 is 9. So we have 9 square root of 3 over 6. And 9/6 simplifies into 3 over 2. So let's move on to multiplication and division. So multiplying radical expressions. So the first example here, if you know how to multiply two binomials, you can multiply two binomials that have radical signs in them. So notice the square root of x times the square root of x is equal to x. Square root of x times 2 is 2 square root of x. 1 times square root of x is 1 square root of x. You can combine those to 3 square root of x. And then 1 times 2 is 2. So let's practice. You can use the arrows, which are typically FOIL, or you can use the distributive property, which either one you like. I'm going to go ahead and color code these as well. If I take the square root of y times the square root of y, that is going to be y. Square root of y times -9, -9 square root of y, -7 times square root of y, and then -7 times -9. And we can combine the middle terms. Important to note, in case you didn't understand why the square root of y times the square root of y was y, is that if you're going to multiply the square root b times the square root b, it is equal to just b. So when you multiply two square roots with the same radicand, the answer is the radicand. All right, let's try another one. 7 times 7. 7 times square root of 2. Negative square root of 2 times 7. And negative square root of 2 times square root of 2. So that is just -2. Combine like terms. All right. You will notice that when we multiply two binomials together, our answer is an integer. The square roots are eliminated. 7 square root of 2 minus 7 square root of 2 is 0. So this is a very important concept. Notice that the two parentheses are the same, except the sign of one of them is negative and the other one is positive. Okay, number 3. We're multiplying two square roots that have the same radicand. So our answer is the radicand. And then we'll simplify. And that's our answer. All right, so now we're going to divide. In mathematics, it's common to write expressions without radicals in the denominator. Quotients containing radical expressions in the numerator or denominator can appear to be different, but actually be equal. For example, 1 over the square root of 3 and square root of 3 divided by 3 represent the same real number, even though they look as though they are unequal. If the denominator of a quotient contains only one term with one square root, then we can rationalize the denominator by multiplying the numerator and the denominator by this square root. So let's look at a couple of examples. So we want to rationalize the denominator. So we're going to multiply by square root of 7 over the square root of 7. And the square root of 7 times the square root of 7 is 7. Number 2, we want to multiply by the square root of 15 over the square root of 15. So we have 5 square root of 15 over 15. Now we can simplify this because 5 over 15 is the same thing as 1/3. Number 3. The radical that is in the denominator is the square root of 3. So let's multiply by the square root of 3 over the square root of 3. And we could also simplify before we start. And I think I'm going to go ahead and do that because 3 goes into 3, 1, and 3 goes into 6, 2. So then I multiply across the top, or the numerators. I have the square root of 3 over 2 times the square root of 3 times the square root of 3 is 3. So my final answer is square root of 3 over 6. Number 4, let's simplify this radical before we just multiply by the square root of 45 over the square root of 45. So that's going to be 9 times 5, 3 times 3 times 5. So this is the same thing as t over 3 square root of 5. So now I'm just going to multiply by the square root of 5 over the square root of 5 to rationalize the denominator. So then I'm going to have 3 times 5. The square root of 5 times the square root of 5 is 5. And one more step. And we're finished. So I bet you're asking, well, what happens if there's a binomial in the denominator? Well, stick around. We're going to answer that question. When the denominator is either a sum or difference containing a square root, we rationalize the denominator by multiplying the numerator and the denominator by the conjugate of the denominator. In this case, the conjugate of the denominator is found by changing a plus sign to a minus or a minus to a plus. So for number 1, the conjugate is 6 plus square root of 3. So we're going to multiply both the numerator and the denominator by 6 plus the square root of 3. So in the numerator, that's 5 times 6 plus square root of 3. And you only need to multiply the first and the last. 6 times 6 is 36. Square root of 3 times square root of 3, but notice it's a minus and a plus. That's going to be minus 3. So we have 5 times 6 plus square root of 3 divided by 33. That is an acceptable answer. If you want to distribute the 5, then we can do that too. And we're finished. Again, we don't need to multiply first out, inner, last, all of those, because we're multiplying by the conjugate, and we would have 6 square root of 3 and negative 6 square root of 3. All right, let's look at number 2. So we want to multiply by the conjugate. So that's 4 minus square root of 5 over 4 minus square root of 5. We need to multiply the first and the last. 4 times 4 is 16. It'll always be minus because one sign is positive, one sign is negative. Square root of 5 times square root of 5 is 5. And 16 minus 5 is 11. If we want to distribute the square root of 2, that would be 4 square root of 2 minus square root of 10 divided by 11. Number 3. So the conjugate is going to be the square root of 6 plus square root of 2. Multiply the first and the last. That's just 6 minus 2. And 6 minus 2 is 4. That's our final answer. And finally, number 4. If you can do number 3, you can do number 4. The conjugate is the square root of x plus 1 minus the square root of x. So we just need to multiply the first and the last. So we multiply square root of x plus 1 times square root of x plus 1. You get the radicand, which is x plus 1, minus the square root of x times the square root of x, which is x. You'll notice in the denominator, you have x minus x, which is 0. So you just have 1 in the denominator. So your final answer is square root of x plus 1 minus the square root of x. All right. So you're wondering, why are we having to rationalize the denominator in the first place? So here's your quick, short and sweet history lesson. So back in the day, if you have 1 divided by the square root of 2, and you did not have a calculator, this was pre-calculator days, and you had to write this as a decimal, then you would have to look on a table of values to figure out what the square root of 2 is. And your table of values would tell you that that is about 1.41421. Which means if we wanted to divide this, we would have some crazy calculation like this. So mathematicians said, hey, if we take this same fraction and multiply it by 1, in this case, the square root of 2 or the square root of 2, then that gives us the square root of 2 over 2. So if we needed to divide that, we would have 2 into 1.41421. And this is a much easier calculation. So that is the history lesson of why you are rationalizing a denominator. But today with calculators, honestly, we're just doing it for some great algebra practice. Hope you enjoyed your bonus content. Until next time, keep doing lots of math. Bye for now.